Dear students, welcome back to our lessons. Today we're going to I'm going to talk about bearings, and we're going to see what is a bearing, and we're going to see also how to describe, using bearings, the position of one point from another. So our topic for today is going to be bearings. You have already done this in years 8 and 9, what particularly in year 9, but we're going to do some revision and continue from there. So it's bearings, and our objective, we're going to have two objectives today. Our objectives are going to be, by the end of the lesson, you should be able to know what is a bearing, and you should also be able to know how to describe the position of one point from another using bearings. So those are our two objectives for today. So let's start from bearings. First of all, you already know two different types of bearings. There are more, but you already know two. And these are the following. The first one is the conventional bearing, where you have a north, a south, a west, and then east, and then we have northeast, southeast, southwest, and northwest. Now that is the conventional bearing. Okay, it's very limited. It's a very limited bearing, and so this is the conventional bearing. And because it is very limited, we are not going to use it in this lesson. Okay, we're going to use what we call the three-figure bearing. The three-figure bearing is built up on the conventional bearing. Okay, so it builds on it. So what is a three-figure bearing? So if I have the same, let's start from these. I have the north, the south, the west, and the east. Now in three-figure bearings, we denote the north by a 0 degrees. So the north, we denote it by a 0 degrees, and to show that it is a bearing, we write in three figures. That's why it's called the three-figure bearing. So we write 3 zeros degrees. That means it is the north. Now, what we need to do is to turn always clockwise. We turn clockwise. Turning clockwise, we will meet all the bearings. For example, when we meet east means we have turned clockwise by an angle of 90 degrees. So east is written as 090 degrees. If you continue turning clockwise, we will meet south. So south is the 180 degree. Continue turning clockwise, we will meet with west, another 90 degrees. So we have started from 0 and turned through an angle of 270 degrees. Of course, continuing in our rotation, we will again meet north, and we would have turned a whole 360 degrees. Now what is so special about this? What is special is that I can tell you to find a bearing, for example, of 20 degrees. What does that mean? It means we're going to start from the north, and we're going to turn just 20 degrees clockwise. If I tell you 140, you turn from the north 140 degrees. If I tell you 200, you start from the north and you turn a whole 200 degrees, and so on and so forth. So that is the three-figure bearing. Now, how do we use the three-figure bearing? So, for example, the bearing of A from P is 125 degrees at a distance of 10 meters. So, let's look at this statement. Let us look at this statement. So what do we have here? We have, first of all, it is A from P. A from P. A from P, meaning that I am going to start from a point called P. So I have a point called P, and if I turn clockwise by an angle of 124 degrees from point P, from the north, and I travel a distance of 10 meters, I will arrive at A. So, if I find the north on P, and I turn clockwise, I have to turn clockwise by an angle of 125 degrees, I will find A. So if I need to draw that accurately, the angle, I mean, let's see. We have the following. Alright, so I have an angle of 125 degrees, as you can see here. Alright, 125 is here. So that's 125 degrees. I have turned clockwise by an angle of 125 degrees. As we can see, so this is 125 degrees. This angle is 125 degrees. This is P. Somewhere on this line, there is A, and A should be 10 meters away. So I can mark a point. I am going to call that point A, and I am going to say that distance PA is a distance of 10 meters. Okay, a distance of 10 meters. So that's how we have changed that statement, the bearing of A from P is 125 degrees at a distance of 10 meters, into a diagram. Okay, into a diagram. Let's do the contrary now. We're going to have a diagram, and we need to describe what is happening. So let's see. I'm going to draw a diagram. So I have a north, I have a point, I'm going to call it A. I have another point, I'm going to call it B. This is an angle of 232 degrees. So how am I going to describe that? So it is the bearing of something from something is, and that's an angle, alright, degrees. So the bearing of A from B, or of B from A. From where are we finding the angle? The angle is found from A. So this is from A. So the bearing of B from A is, and what is the clockwise angle? The clockwise angle is 232 degrees. So to describe this bearing here, okay, we need to write down that sentence. The bearing of B from A, if you are at A and you want to find where is B, you have to turn clockwise, is 232 degrees. Okay, let's find another example. I've got A, I've got B, I've got an angle here of 35 degrees, and I'm going to ask you to describe, number one, the bearing of B from A. Describe the bearing of B from A. So, I'm going to give you a few seconds chance. This is the north. Okay, the bearing of B from A. So the bearing of B from A is and all those of you who said or who managed to come with the answer of 35 are correct. But how are we going to write it down? Remember that we need to write a three-figure bearing, so you don't need to write 35 but 035 degrees, and that is correct. And let's see another one. If we need to describe the bearing now, the bearing of A from B this time. I need to find the bearing of A from B. Not B from A, but A from B. So we need to start from B, and we need to turn clockwise until we meet the line which leads us to A. And we don't have that angle. Is there any way how we can find that angle? Of course there is. There are more than one way. For example, I know that this angle is 35 degrees. And I know that this angle here and this angle here, they are called interior angles. So they are supplementary. So they add up to 180 degrees. So this angle here, angle B, obtuse angle B, is 180 minus 35. So that's equal to 145 degrees. What does that mean? That implies that angle, reflex angle B, so is 360 minus 145, which is equal to 215 degrees. So we can say that the bearing of A from B is 215 degrees. Okay? So that's how to describe the bearing. So you can either have a diagram and you need to describe, or you have description and you need to draw a diagram. Okay? Hope you have understood our lesson today. See you next time.